This code is provided manned your Google Drive in a Google Colab environment, and then list all the files and folders located with your Colab notebooks directory on that drive. The second image is all about the import statement. First, numpty as np for numerical operation and array manipulation, panda as pd for data manipulation and analysis using data frames, matplotlib.pilot as plt for creating basics plots and visualizations, Seaborn as NSS for creating more advanced and statistically oriented visualization built on top of matplotlib, train, test, split, a function from sklearn.model selections used to split datasets into training and testing sets, Gaussian NB, a class from sklearn.naive-Bayes that implements the Gaussian naive-Bayes algorithm, a probabilistic classifier. Classification report, confusion matrix, accuracy score, functions from sklearn.metrics used to evaluate the performance of classifications models. The third image is all about load the dataset. The code first defines a list of column names for the dataset. Then, it uses the Pantai library PD to read a CSV file name, PEMA, Indance Diabetes.csv, located in a specific Google Drive path. While loading the data, it explicitly assigned the previously defined column list as the header of the data frame. The fourth image is all about the features independent variables and the target variables dependent variable. It assumes the target variable is named outcome or diagnosis, where 1 represents the presence of the condition and 0 represents its abscess. The 5 code is all about the split the data. The code uses a variable name model, which is assumed to be a trained classification model, to predict the target variable for a test dataset named xtest. The prediction is stored in a variable called ypred. Finally, the code prints the 10 first predictions from the ypred array to display the model's output on the test data. Make prediction is focused on ypred equals model that predict xtest, using a trained machine learning model to generate prediction on a test dataset. Print first 10 predictions, displaying the first 10 predictions made by the model. Evaluate the model. First, calculate accuracy. It uses accuracy score to compare the true levels of the test set with the model's prediction and print the calculated accuracy. Second, display confusion metrics. It uses confusion metrics to create a table that shows the counts of true positives, true negatives, false positive, and false negative. Third, display classification report. It uses classification report to generate a comprehensive report including precision recall, FY score, and support for each class in the classification task. Visualize the result. Uses Seaborn heatmap to display the confusion matrix as heatmap. FMT formats the annotation as integers. CMap blues set the color scheme of the heatmap to shades of blue. CBar false hides the color bar. Labels the x-axis as predicted. Labels the y-axis as actual. Finally, PLT that show display generated heatmap. And the last, the code import numpty and grid search CV from sklearn.model selection, and then define a parameter grid for var smoothing hyperparameter. Finally, grid search fit xtrain/ytrain is used to train the grid search CV object on the training data xtrain, ytrain. This process will systematically try all combination of the specified hyperparameter values evaluate their performance using cross-validation, and identify the best set of parameters. That's all. Thank you for watching my presentation.